Today we will talk about the semantic fingerprint and the semantic hash code from AI1. The semantic fingerprint can be compared with the forensic fingerprint of your fingertips. In other words, the semantic fingerprint is a unique profile or identification of a text corpus, like a paragraph. The semantic hash code is the transformed and converted logarithmic number representing the semantic fingerprint. The number represents the context, the message, the meaning of a paragraph which have been analyzed by the semantic fingerprint. BrainDocs AI is the software solution where software agents are using the semantic fingerprint with the semantic hash code. In other words, BrainDocs AI is a piece of software which analyzes any kind of text, paragraphs in any kind of language, and detects the message, the meaning of those paragraphs and stores it as a semantic fingerprint. So far so good, but how is the semantic fingerprint recognizing the message, the meaning of a text corpus? Well, the way how a text corpus is written and the way how the words are placed in order in a text corpus is not accidentally. It is based on the grammar of the language used. And therefore, the grammar is an inherential part of the corpus itself. And so the ability to recognize this inherent intrinsic structure of the text corpus leads to the fact to understand the meaning of that text. Every word has a relationship with every word in a text corpus. And based on the grammar rules, the words are more important or less important based on the context in the text. That means sometimes a word in a given context is more important, but the same word in another context is maybe less important. And to visualize, we can show the relationships by colors, for example, in this text. And we will recognize that some words are more important and others are less important. And together, the whole paragraph will form the message. We can call it intrinsic semantic. So that's the given generic semantic based on the words used in this text corpus. We name the important words in a text corpus bearing words. Those are the words which are forming the message, the meaning of a text. And the whole process is not done in ASCII level, it is done on binary level. So our system doesn't recognize ASCII character, it recognizes only on binary level, which means we are totally language independent. And the system views every bearing word as a small sub-fingerprint of the whole paragraph. In other words, every paragraph has a fingerprint for the paragraph, but there are multiple sub-fingerprints building the bearing words, or in a neutral way named the data spots, which are formed out by the bearing words and all the relations between the data spots. We easily can visualize the intrinsic semantic or the semantic fingerprint of a text paragraph like shown here. The dots represent the importance and the connection between the bearing words, and that's how the message, the semantic message, is formed. We call it fingerprint because the form how we create this semantic fingerprint remembers very strongly to the form of the forensic fingerprints. The last question was, How do we store the semantic fingerprint? We did not want to store a graphic or a vector graphics or something. There are a lot of data in this format here, and in order to be efficient and fast in the processes, we needed to come up with an idea how to store that. The solution was to create a semantic hash code, which is nothing else than a logarithmic number. And so now we can store and represent every fingerprint with a single number. And in order to match and process those numbers, the process can be very, very, very much simplified, and it will be very fast. Comparing or matching or rating documents, paragraphs is very easy now, because all you need is you have to compare the fingerprints of the documents or paragraphs which are stored in databases or as a single document or in a file share. It doesn't matter. The system just matches those numbers and will rate the match quality with the number. Because the fingerprint is able to store concepts, ideas, messages, we're not having just words or keywords. We are having a whole message or a question or an answer. So you can match questions or ask questions and force an answer, or having an answer and looking for the question for it. So it is much more intelligent than using keywords or ontologies or taxonomies to match information. This is a real questioning system that transports answers, concepts, and ideas. So the semantic fingerprint transports not only ideas or concept, he transports knowledge. And so we can fingerprint my knowledge and generate a digital twin out of the fingerprints of my knowledge, and hand that over to software agents which are carry on my knowledge. And so I can multiply myself for any kind of actions, maybe search or maybe building up project ideas, brainstorming, whatever you like. I hope we have found your attention, and if you like to have more information, please visit one of those websites and contact us. Thank you very much.